Please, the show starts in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, go.
Okay, hello everyone. Can you guys hear me clearly? Can hear me, right? Can anyone have to confirm? Okay, cool. Okay, let's get started. So today we have 12 people now. Okay. So today I continue to solve on-site interview problem on Leetcode platform. As you guys know that Leetcode platform is very good for us to practice to code to solve coding to improve our coding skill. A lot of big company that pick a problem from Leetcode. Okay. So for the newbie who coming to Leetcode at the first time, I highly recommend you guys can solve the top interview questions here, so you guys can sharp your coding skills, so that you can continue to join like daily challenge. Let's have a daily challenge here, right? And also, I highly recommend you guys to join Leetcode contest as well. Let's have the weekly contest. This happen every week, and bi-weekly contest. This happen every 2 weeks, right? Okay. If you guys in the top of a contest, you guys can earn a lot of coins. So you guys can redeem the reward like t-shirt or laptop sleeve or premium account in Leetcode. Okay, so today I will continue with the interview assessment, mock assessment. This feature is for premium user only. Actually, that Leetcode will prepare a problem set based on the company. So each company will have an online assessment, phone interview, and on-site interview. Okay. Okay. So let's get started. Because for Facebook on-site interview, I already solved all problem. So today we'll continue with Google. Google have a problem set 16. Okay. So when I start mock the assessment, if you random problem set, and each problem set may contain up to 4 questions. Okay. Okay, so let's get started. So when I solve my questions, if any guy have any questions like want me to explain the problem again, or want to want me to describe algorithm again, or something, you guys feel free to ask. Okay, let's get started. Oh, today we have only 3 questions. Okay, on the first question, right? Given two string S and T, determine if they are isomorphic. I'm not sure what isomorphic here. Okay, two string S and T are isomorphic if the catchers in S can be replaced to get C. All occurrences of a catcher must be replaced with another catcher while preserving the order of catchers. No two catchers may map to the same catcher, but a catcher may map to itself. Let's consider example 1. So this is the example 1. So uh, all occurrence of a catcher must be replaced with another catcher while preserving the order of catchers. No two catcher may map to the same catcher. No two different catcher, right? Map to the same catcher, but a catcher may map to itself. Okay, so in this example, we need to check if all catcher in S can be replaced to get T, right? This is the target, and this is the source. Okay, so in this S here, we just replace E by A, right, and G by D, so we can get our target string here. Okay, replace E by A and replace G by D. Okay, so it can we return 2. Let's consider the second example here. Example 2. Okay, F here, we need to replace to B, right? Okay, O here, if we replace to A or R, right? So if you something like B, if we replace O by A, if you B A, because we need to replace the whole occurrence of a catcher with another catcher. Okay, so this cannot map with this one, right? So we return false. Okay, here we map F with B and O with A, but cannot. Okay, so return false. The same with this one. This example 3 here. Okay, T here we map with T, right? So we have T and T here. So let me copy the new one. Okay, B here, right? If we map with T like this, if we map with A here with I, it's like this. If we map E here with L, E here, right? E here with L, it should be like this. And we can map R here with E. So can, right? Return 2. Okay. So we understand the problem, right? Okay. Two catcher may map to the two catchers. No two catcher may map to the same catcher. No two different catcher map to the same catcher, but a catcher may map to itself. So a catcher may map to itself, meaning that ignore mapping. Okay. So how to solve this? So okay, we just do intuitive way, like we mix E, right? All the length are the same, right? The length of the length the same, and S and T contains valid ASCII catcher or ASCII letter. So E here we can replace, if we replace E here with another catcher, so we need to replace all occurrence of E as well. Okay. Okay. So how about that? We can normalize both string. Like for example, that if like this, right? We normalize string S here with something like we mix the first catcher, right? We map it with A, and we mix the second catcher, right? We map it with B, right? So we have something like a mapper, a string mapper. So we have the next catcher, something like this. We initialize by A. So E here we have one map yet. So we map it with A, map E with A, and move the next chair will be B. So we set E here with A, and when we go to tree, right? Tree not in the map yet, so we will map tree with a next catcher. In this case, will be B, and we just replace B and make the tree here. It's already in our map here. We just use it. So ABB. So do the same with T. So we can also map it the same like ABB. So finally, we just compare if S and T are the same or not. Yeah. So by this way, we can do linear timer. Okay. This can work. Okay. Let's check. Okay. I will implement a function like normalize them together, like string S here. I have a next catcher will be A, and have a map here. Okay. Map for your dictionary. Okay. And I look through my string if S here, C here, right, not existing into my map, right, I will map C here with a next catcher here. Okay. And I change the next catcher to be the next one. So it will be, I will get the S key, right, S key and plus 1, and convert it into the catcher. Okay. Okay. So I need to have something like right here to store the result catcher. So I append it with the string of C, right, because it's already mapped here. Okay. And finally, we just join the catcher together. Okay. And finally, we just return if normalize of S equal to normalize of string T. Right. Let's check if it works or not. True. Okay. True, false, true. Seem correct. So we have a normal function here. Next checker will be A, and have a map here. Answer is the result here. We traverse catcher. If not mapped yet, we map it with the catcher and move catcher to the next catcher. I get ASCII plus with 1. Okay. And append that catcher. Okay. And joins together. So finally compare them together. They the same or not. Okay. Let's run. Okay. So we can solve like this. Okay. So for the time complexity, it will be length of S, right, plus with length of T, right? And by complexity will be the same. Will be length of S plus with length of T, right? Okay. Anyone have questions? This problem seem intuitive. Seem like easy problem. Okay, I think we can go next. Go next. Okay, question 2. There is an exam room with n seats. Could you please tell what kind of this problem? What kind of this problem? This problem seems like just a mapping problem. Just your mapping problem, something like that. There is no special here. Just a mapping, maybe. I'm not sure. Mapping problem. Okay. Let's go to question 2. There is an exam room with n seats in a single row, labeled from 0 to n-1. When a student enters the room, they must sit in the seat that maximizes the distance to the closest person. If there are multiple such seats, they sit in the seat with the lowest number. If no one is in the room, then the student sits at seat number 0 beside a class that simulate the mentioned example room, implement exam room class. Exam and here initialize an object of exam room with the number of seats and in seat here return a label of the seat with the next student will set leap here indicate that student sitting at seat BP will leave the room. It's a guarantee that there will be a student sitting at okay, guarantee that P here exists. Okay. You mean hash map problem? Yeah, I think hash map problem. Yeah, this just use simple map here. Can be considered like a hash map problem. Okay. Let's go through example. So we have an example here. Initialize with the n equal to 10. Okay, and then 10, right? Okay, when it call sit 0, right? Return 0. No room, no one is in the room. Then the student sits at seat number 0 because number is start from 0, right? If no one is in the room, then the student sit at seat 0. So the seat will start from 0 into to n minus 1. When a student enter the room, they must sit the seat that maximize the distance to the closest person. Not sure that the sheet is in the single row, right? So it's something like 0, 1, 2, 3, 4 minus n minus 1. Okay, so you are tab. Okay, so okay, so when we assign, right? When we assign the new seat, we need to maximize the distance between closest. For example, that if the first is 0, then the second one will be n minus 1, right? Am I correct? Let's check. If seat must sit on the seat that maximize the distance to the closest person. If there are multiple such seats, they sit in the seat with the closest, with the lowest number. If no one in the room, okay, start with 0. Okay, so in this one, no one in the room, right? So the first seat one will return 0 because no one in the room, and this one is already have the person. Okay, a person. Okay, then seat here, right? Will return the number 9 because this is the 4 have the maximum distance compared to the closest one, 0 here. So it will return X here. Will be 9, right? 9 here. Okay. Okay. Then seat return 4. The student sit at last seat number 4. Number 4, right? Why number 4? Because this is you have the fixed number, right? Let's have the specific ID here. Okay. Okay. So we need to find the middle here because when the middle, right, the difference between the closest will be maximized. So it will return the seat number 4 here. So the distance here will be 3 or 4. Distance here will be 3, right? And distance here may be 3. Okay, and distance here may be 4. So 4 and 5 still correct, but we need to return the lowest number. Okay, so it will return 4 here. Okay. Okay. Sit here we return 2. Sit here we return 2. Okay. So when we okay, sit here return 4, right? And when we equal sit again, it need to return 2. It can this one, right? This one also 1. The distance between the closest E1, and this one the distance between closest is also 1, and this one closest which the distance between closest still 1. So they will choose the small the lowest ID. So it will return 2. Okay. And when it leave 4, so this one will be removed. Okay, be removed. Will be removed. Okay, and continue with sit of sit, right? So it will return this one 5 or 6, right? This one 2, and this one 3. So it can 5 or 6, but 5 have the lowest ID, so we return 5. Oh, and here too big, and here too big, and here is too big. It's a guarantee that there are students sit at P, and at most this one core number of cores. Okay. 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 And here is too bigger. So if we so when how to find the distance that the index that have the maximized distance. So because n here too big, we cannot create a array for it. Cannot create array. So we just we have the run from 0 here until n minus 1 here. So the first one it will return 0. When it empty, it will return 0. It gives the first case. Okay. So the first case is when it empty, right? We need to return 0. Okay. When 0 here is used, and when 0 here is used, we may have a map to store their currency, because we can store in S index because n here is very big. So we have something like a map to store, like I already used 0 index here. Okay. So when I call the next one, right? When I call the next one, maybe I find for each ID here, right? I may store in the increasing order. For example, so that I can find the distance between them and to the minimum and to the middle. The first one will return 0. Okay, the first one will return 0. The second one we need to return n minus 1. Why? Because we have a interval. So we have from 0, right? We have an interval and at n minus 1. We have the interval, so we need to pick the last one because it's have the maximum distance. This problem quite hard, not easy. Okay, so first of all, you return 0, right? So the second one, if someone return 0, if someone remove 0, right? So we need to add 0. We need to something like let's from an example here. First of all, if you accuse 0 here, and the second one, we can see that we already accuse 0, right? So we have available from 1 in up to n minus 1. And we check that we still have ID here would have the maximum distance. Okay, for the last here is have the maximum. This problem is quite hard. Maybe we will switch this problem later. Let's move to question 3. This question is hard. Okay, let's move to question 3 first, and then we come back to this question later. Okay. Given an encoded string, return its decoded string. Okay. Encoding string rule is okay. So okay. Given in encoded string, return decoded string. Encoded string rules like k encoded string, where encoded string is inside a square bracket is being repeated exactly k time. Note that k guaranteed to be a positive integer. You may assume that the input string is always valid. No extra space or square brackets are well formed. Furthermore, you may assume that the original data does not contain any digits, and that digits are only for those repeat number k. For example, that there's one input like this one or this one, right? It need at least have the bracket, and this one inside the bracket need to be a lowercase letter, right? S contains lowercase letter digits and a square bracket. S guaranteed to be a valid input, and all the integer in S are in range 1 into this one. Okay. The encoded string can be inner, can be can be netted, right? Repeat assume that input string is valid. No extra white space, square bracket are well formed. Okay. Furthermore, you may assume that the original data does not contain any digits. The original data does not contain any digits, and that digits are only. So if it have a digit, right, then those digits are only for repeat number only. So it means that the inner here should be a catcher or the netics as well. Your English is easy to understand, but I have one suggestion that you remove R. Okay. I think we can use stack to show this. Seem is need to stack recursion. Okay. So okay. Let's solve this problem first. This problem may be a bit hard. We will get back later. Okay. To save our time here. Okay. So for this string, right? So because it have the netics as well. So we just like we scan through our string here. When we make the digits, right? We calculate the real number. Okay, so we have 3 here, and we have this one and this one. So we need something like a stack to map the open bracket with the close bracket. So we can have the index of this index and this index. So we can get the inner value of it. Then we time it with the number. Okay. The same with this one. We have 2 here. We have the stack here, right? So we solve this problem. So what happen if the string? What happen if yeah? So when it is a single, right? It doesn't contain the number 1 in the first line. Yeah. So this can be correct. So we just call the recursive to solve the sub problem. For example, we solve BC, right? It will return BC and we multiply with 2. We solve A, right? It will return A and we multiply with 3. Okay. So let's jump to the second example here. Okay. For this, right? So we have 3 here, and we map. We will have a stack to map open here with the close here, right? When we solve this problem, okay, and we multiply this number with the result of this, okay. Seems straightforward. Okay, so we just need like a stack, okay, in our string here. So stack will help us to map open with the close. Okay. Have map open with close. Okay. Then we need to scan our string here. So if not a digit, right, we include here. Okay. Then if we meet a number, right, we meet a number, then meet a number and we scan all the number. So until we end, we meet this one. Okay, so we have something like a temp number, a number equal to 0, and we have the string to store ABC here as well. Temp string to store ABC as well. Temp string, okay. If A is here, E equal to a digit. How to check a digit? So I check by ASCII. Okay. If it is a digit from 0 until 9, right? So it's a digit, right? If it's a digit, I just get the number by that ASCII. Get its integer value, and I multiply by previous one with 10 and plus with the current one, so I can get the current number here. Okay, so I have to need to have an answer as well. Okay, so if I mix something like a digit, right? I need something like a digit. I need to check if the length of temporary so far is greater than 0, right? We need to append it into our answer and set it to empty, right? Because in this case we A, B, C, we need to append A, B, C. When we make 3, right, we need to append A, B, C. Okay. So append to my answer here. Okay. Okay. Then I have a num here. Okay. Else, if else, I meet a catcher. Okay. A, right? A letter. Okay. If it's a letter, then I just append the string. Okay. For example, I append ABC here, and I make this one. Okay. Else if it's is open, right? Open and make a stack. Make a stack to store that index. So I maybe I split stack. So when I saw this one, right? So when I make this one and I make this one, if I append to the stack, so I don't need to append to stack. I just need so first of all I need to have something like a group. So by a close matching of a open, and then I just scan first, scan to get the close matching first. Okay. So if I have a stack here, if C here equal to this one, I just append the index of that. L is a close, right? Close here, close. Okay. Then I map them together. I map close matching of pop here will equal to I here. So this is the open index, right? I map close index of the open is I here. Okay. Then I yeah. So after this one, I have the close matching. I have the close matching. Okay. So if I meet this one, right? I meet this one. I need to find the close matching. So close index will be close matching of this index. Close matching of this index. So I have the close index, right? For example, let's say I will have the close will be this. So I need to get substring here to solve the substring problem. So I need to solve problem by recursive function of the substring problem. Substring problem will be the string f, right? Start with this one plus one, the open. This is the current open index, right? Plus one. We have this one, and we have the close index here, right? We because it's the inclusive, so we up to close index here. Okay, because it's inclusive. Close index here, right? Inclusive, so if we will get A2 to this one. Okay, we solve the sub problem, and when we need to multiply a number x, when x have the this form, right? So it need to have a integer in the front, so we need to multiply by this, and we append to our answer. Okay. So after like this, right? After this, we need to continue or we can call a recursive function. We can continue our logic here, or we can call the recursive function. So let's continue our logic here. Okay, so this one we don't use this one anymore. We have something like yi here less than length of s here. Okay, we have I equal to 0 here. We have the current character we si here. So we continue our flow by the I here, right? We jump to the close here, right? And plus 1, close here, plus 1. Okay, close here, plus 1. And we need to reset the num to 0 and the temporary string to empty. Okay, and finally we join our answer together. Okay, let's remove buckling. Okay, let's check. I need to increase I as well, right? Need to increase I as well. So it is digits. I need to increase I. The number increase I. It's open. I will move to the next one and reset all the value. Okay. Okay, it is a number, right? It is a number. It is a number here. So it have the string we append, and we set the string to 0, and we calculate our number here. Okay, plus 1. How about if it's a string here? We just append, right? Just append. Okay, seem work. We have a close matching here. We have a substring here. So substring here multiply by number here. Okay, we go to the next one and reset themselves. Okay, let's run. We need to enumerate. So it's return empty string. Seem something wrong. Okay, we are running this one, right? We are running this one. So this one will we need to have the left side, right? So for example, if we show A, right? We show A. This one just append temporary string here is A and finish our flow. So we need to check if the length of temp string here is greater than 0. We append to our answer. Append to our answer. Do we need to care about num? No need, right? Because when it happens num, you need to have a bracket. So no need to care num. Okay. So we have A here, right? BC and BC, correct? Okay. Let's check another test case. Okay. ACC, correct? Okay. And this one will be, let's copy math, right? Math. So seem correct. So let's make seem use stack and recursive, right? Both recursion and stack similar with the bolded notation. So let me analysis the time complexity and space complexity. So this is the linear time, right? Linear time. This also a linear time, but it solve the sub problem here. It may solve the sub problem here, and this sub problem here. In case the sub problem may have a lot of netics, so we need to scan hard. Okay, so this is a linear time, right? And it shows the sub problem here, sub problem. So in worst case like this, right? And now we show the sub problem here. So we have this one to scan through. We need to scan first, or this one you take on, and we show this one, and this one scan through our string again. We take on again, so n square can work because the length here is very small. Actually, that length s square, and we can multiply by this cost, because this cost we multiply string by the we consider the maximum. So this cost as well by complexity will be the output. So the output maybe length string multiplied by this one. Okay. Super good one. Why calculate open and close bracket every recursion call? Close matching will be the same for every recursion call. Yeah, we can optimize by we can optimize them by we compute this one once. So I need to define another function for it because I review this function. So if you want to review, right? So maybe I define another function like recursive or DFS or something like this. Okay. This one I just calculate one, right? And I don't I need to consider about the start, the left and right only, right? So I just return my DFS here from left will be 0, right? Right here inclusive. So I will length s here -1 here. So this is calculate only once, right? Calculate only once, and this one will left to right here. So this one will start with left, and this is greater or equal to right here. Okay, and I here +1, correct? Okay, and this one I here correct. So this one instead of get a substring, right? Instead of get a substring, I will call the DFS function. What's the left will be I +1, and right will be close ID -1, because right here is index and inclusive. Okay, remove the substring here. So now we can calculate this one once. Okay, let's check. Okay, can, right? Okay. Also can. Okay. So by using this, right, we don't scan our whole string again. So we can so for this, right, for this it will scan only once and found this one, and this one, right? So this one it will just do the linear time because it will scan linear in the string only once time, because when it meet this one, right, it jump into this one, and it iterate and it solve this problem by jumping. So every character is only visited once. Every character is only visited once. So we have the time complexity will reduce to length of string multiply by this cost by multiply string here, right? So it can reduce the time complexity. Yeah, nice suggestion. So let's come back to the question 2. Okay, for the question 2 here. First of all, if it's empty, right, it will return the 0 here. From the 0, we have a maximum in 9. We can by research, right? We can like we have a range, have a available range or something. Have a harder. So it is 0, right? So we need to find the maximum. We consider from it here, right? Each element here. So 0 here. Next of it will be only 9. So we 9, put 9 here. Okay. And then we have our sit here will be 0 and 9, right? So we have the interval here from 0 and 9. And the interval here have length will be 9 minus 0 plus 1 will be the interval here. We have the length will be what is the length? The length will be 9 minus 0 minus 1, right? So it will have the length of A, right? 1, 2, 3, 4, 5, 6, 7, 8, right? Okay. So we have 9 here minus 0 here minus 1, so we will 8. So we have the length A here. So if we use the middle, right? Use the middle, this will have the y is A, but when we divide it's an odd number. A, right? A. But when we divide, it's the divide. It have the 3, and this have 4. Y8 divide 2. It's an odd number. Why? Maybe it's a Q, this one. So we made something like we have the length will be A, right? We divide will be 4. But this one is 3. Maybe we minus 2. So we have 7 here. Divided by 2 will be 3. So we have if we put one element into this interval, right? So we have the distance will be 3, and we consider another interval like for something. It have another interval like this one, something like this. So we need to consider as well to choose the which one would have the maximum interval when we put into it, right? So okay, so how to calculate the index? So just the length here plus with the length here, we have something like this is the interval length, the size will be this one, will be something like this, left and right, right? So we have the formula like right minus left minus 2 and right minus 2 and divide by 2, something like this. So we can have 3 here, and this will plus with sign. So we can have this index 0 plus with 3 and plus with 1 as well. So we have the index will be 0 plus 3 plus 1 will be 4. Okay. And we just go through each interval. If have here we just have one interval from 0 to 9. So we need to output 4 here, okay, 4 here, and we need to push 4 in our array here. Okay, we need to push 4 in our array here. So now we have 2 interval here from 0 into 4, from 4 into 9. We need to calculate the size. The size of this one will be like 4, right? Minus by 0 minus 2 divided by 2 will be 2, right? 1 will be 1. Okay, check if it's 1 or not. In this, right, if we push into this one, the maximum distance will be 1, right? Will be 1 here. Will be 1 here. Okay, so it's correct. Our formula is correct. So to get the index, so we just let here will be 0 let index, right, will be 0 here plus with the size and plus with 1 will be 2, right? Index 2 here. Okay, so if we put into this interval, it will have the distance will be 1. The distance will be 1. What happens if we put into this one? Into this one we have the size 1, right? And size 2. We what happens if we put into this interval? So we have something like 9 minus 4 minus 2 divided by 2 will be 5, right? Minus 2 will be 3 divided by 2 will be 1. Okay, and the index 1, right? So if we put into this one, it will have the distance we will want. So both are the same. So we just use the first one. Here we are consider it's a this is the length here is the even number, right? And this is the odd number, right? 9 minus by 4 by 5 odd number. So in our formula here work for both odd and even. So it seems correct, correct formula. So because the number code here is bigger, can we do a linear? Can we do a linear scan each time? When it sits, we put. I think we can do the linear timer, because this is not very big. I think we can do the linear time to scan our interval here. But the first one is when it empty, right, we return 0. But when it have the one element here, so how do we know that we need to return this one? Because we have no interval, because this is 0 and we have no interval. So maybe we can check something like if empty, right, we return 0. But if it have one element, right, say one element, right, so we need to consider two sides from so when the size is 1, right, it's always the 0. When size is 1, it's always 0, because when it's empty, it's always 0, right? When what happens if someone puts 5 and delete 0? So it's not always 0. It's not always 0. So in this case, when x size is 1, right? So we need to consider from 5 into 9. So we have something like when x is from left to blah 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 to right here. So this right or left here is not, we don't need to divide. We don't need to divide. So we just consider the internal first, the internal first, and then we consider two bound, the right and the left. Okay. Okay. So let's try to implement. Okay. First of all, we need to store n here. Okay. And we need to have our array here. Okay. And when we seek right, we our array here need to be sorted. So when we insert in sorted order. Okay. Okay. How about when it's right, length right, up sorted array here is empty, right? We return 0, and we need to set sorted array here is 0. Okay. If one element, we don't have the internal interval, we just consider the left bound and the right bound. The left bound, we need to have something like max distance so far. Max distance so far. Initialized by 0. Okay. So when and we need to have the answer so far. Answer so far will be something, any value. Okay. We need to the left bound, right? Left bound, we need to get the sorted array of 0 here. So we have something like from to the sorted array 0 here. Okay. And the right bound is something like we have sorted array here with the last element with this one. Okay. So we need to consider the left bound. Left bound by this one. So if we pick 0, right? If we pick 0, so the distance will be 0. Will be this one minus with 0. For example, if this one is 1, right? If this one is 1, the distance will be for example that 1 and 0 and 1, right? And for example that this is already acute, and we have the 0 here. So the distance, between the distance, if we set like this, the distance will be 0. So we have something like this one minus 0 minus 1. This is the max distance so far, and the answer so far will be 0. Okay, this we consider the left bound. let's consider the right bound. The right bound, we have this one, something like, for example, that we have 9, right? And have 9. So the distance. Actually, that because I here I'm consider the distance as this interval. I don't include this one. Distance can be considered as a random sum. Okay. Okay. Consider the left bound and right bound. Right bound here will be the distance will be n minus 1 minus with the cell dot socket array of the last one, n minus 1. For example, this minus 1. Okay. Okay. If the distance here, we need to find the maximum distance, right? So if the distance here is max compared to our current distance, update our max distance to be this, and the answer here will be, because I'm pick the last one, right? So it will be n minus 1. Okay, and I am consider the internal interval. Okay, when I consider the internal interval, right? Internal intervals. I just look through my internal intervals. Look I in range of length of my static array here minus 1. Right. So I'm consider internal between the start here will be cell dot static array of I, and the next one n will be cell dot static array of I plus 1. Okay. I'm consider this internal interval. I use my formula like this. Alright. I just copy I have the distance here will be right minus left here minus 2 here. Okay, this one in Python need to care about this. Okay. Then I just have the index here. So if the distance here is greater than our current distance, right? So update our answer to be the start with 1 plus with the size here, right? The distance here plus with 1. Okay. So finally, we just return our answer here. So when we have the answer here, we need to insert in our current array. So the static array here, we have a function like insert, right? Insert our array here with the value answer here. Return our answer here. When we leave, right? We just delete. How to find delete? How to find delete? How to find delete? How to find delete? Delete an element in array Python. Pop. This is the index. How about we pop a value? Remove b here, right? Maybe remove maybe cell dot static array dot remove p here. Okay. So let's test that. Let's test. Right here is not defined. Line 28, not right. Start and end. Remove X. X is not inside the list. Why? Why X is not in the list? Because it's a guarantee as you discuss further. Let's check later. Okay. Not will discuss. Remove value here, right? Why is not exist? Let's bring our in stock here may not work. So we have why a lot of zero here. Something wrong. Something wrong. Maybe we need to debug. Why put a lot of zero here? Distance you consider a random sum. Okay, let's jump into my compiler. Sell the sort here. Mark this is this equal to this. Why? Let's debug. In shock here. Yeah, bisect dot in shock. Bisect dot in shock. Remove this one. Bisect here. Okay. In shock here not correct. In shock. Python. Insert here. Insert into array, right? With the value, right? Correct, right? So why something like not found? It is not invoke not correct library. Okay, now it's correct now. Okay. Let's debug. Let me zoom the size a bit from here. From here, right? Okay, B20. Okay. So I bring my this one is a structure, not a straightforward data. So let's debug on the Leetcode platform. Okay, a bit slower, but can find. Okay, so first of all, you see 0, right? You return 0, right? And our array will be we will be 0, right? Okay, we return 0. Okay. The secondly, we expect to return 9. So it have the one boundary. This is -1, right? Mark this view -1. Yeah, okay. So the disk here, you A, right? We need to use this. You need to use this. For example, in this, right? I cannot change where I debug. So this have the distance A, right? This have the distance A, right? Okay, A here. If I push here, so the distance will be A, correct? So this here is greater than our current mask disk. If you and the answer will be 9, right? Answer will be 9. Okay. And it look through this one will be empty, right? Okay. And then it insert 9 here, correct. So return 9, correct. Return 9, correct. Let's continue with the 4 here. 4 here. The left bound will be -1. And the right bound will be -1 as well. So if you use and pick the interval from 0 into 9 here. Okay. Start will be 0 and the end will be 9. And will be 9 here. Okay. And the capital distance will be distance -6. Oh, this one end minus start. Siêu lý bức. Okay. So 0, 9, 4, 6 here, which is not correct. 6 here, which is not correct. So we need to debug again. We only consider when it's greater, right? Something wrong again. Debug again. Debug again. Let's debug again. Okay, we have cell of a static array empty, and we have max distance and distance. Okay. Okay. We continue. So we have 0 first and 8. Okay. We put 4, right? With 4, correct. So this one we return 6 instead of 2. Y return 6 instead of 2. Y. This one 1, right? This one also 1. Y maybe we need to consider the internal before. Okay. A bit disconnect. So it's reconnect already, right? Okay, let's continue. So the left bound will be -1. Don't consider, right? The right bound also -1. Okay. Then the start will be 0, right? And this one will be 4, right? So this distance will be 1, right? 1, right? Okay. 1 greater than max. It will have the index will be start 0 here, plus with 1 and plus with 1. So it will answer will be 2 here. Okay. So consider with the 4 and 9 here. So the distance will still 1, right? Y. Oops, I haven't updated the max distance. Why I'm so bad? Why I'm so bad? Why I forgot this silly? And I need to consider the interval before the right bound to pick the minimum. To pick the minimum number. Okay, let's run. Okay, 0, 9, 4, 2, noon, 5. Let's make. Okay, cool. Cool. You must. Do you guys have any questions? But I don't still get the main idea of this problem. Okay, so the main idea of this problem is that I maintain the array here. I maintain array here. Array here is assigned assigned sit that already assigned. Okay, we maintain array here is the sit that we already assigned. Okay, so when the empty, right, when it's the empty, right, we need to return 0, right? So we already assign 0 here. Okay, else, so we need to consider the left bound, the right bound, and the internal one. Okay, for example, that when it have consider this one first. Okay, so when it call this line, right? Call this line, right? It's an empty. We need to return 0. Need to return 0 here and abandon 0 here. Okay. And then we call sit again. So we consider the left bound of this 0 here. So the distance with 0 will be -1, right? The current here with the right the left bound will be 0, will be -1, and the distance from the right bound will be from 0 to, right, to the right bound will be -1. So the distance here, so will be this one will be 8, right? So this distance is greater than the left bound distance. So it will update. The answer will be 9 here. And there is no internal, right? Because the size is 1. Because in my internal intervals here, I look from length of this one -1. So it's length this one is 1, right? -1 will be 0. So this one no run. So I have the answer here will be 9. And I abandon 9 here into my array here. Okay. Okay. And when I make I call sit here, I will check the left bound again. Left bound distance is -1. The right bound distance is -1. The internal ones, the distance will be this one will be 3 here. Will be 3. This one already occupied, right? The distance here will be 3. And distance here, the distance here is 3, right? When I use x here, the distance here will be 3. Will be 3, right? I only consider the size, the minimum size between them, because it's different only up to 1 element. So I consider this the distance. So if I put into the middle, because it's only have 1 interval, right? So if we put this interval of the middle of from 0 into 9, we have the distance will be 3, will be 4, right? 4 from them, right? So we choose this. So we push 4, right? Okay. And now when we call sit again, right? We check the left bound. The distance will be -1. The right bound, the distance will be -1. The interval, the distance here will be 1. If I put 2 here, right? The distance will be 1. If I consider this, right? And I calculate the distance here also 1. So I will choose the first because it don't update. It only update when the distance is greater than current maximum distance so far. So choose here. return true, and append true. So now when we call lib right, we just remove 4 here. Okay, when we call sit again, right, consider left will -1, the right -1, the interval here the distance will be 0. Distance will be 0, and this one right, we already remove 4 here. This one right, the distance will be 2 here. The distance will be 2, right? So if I put this one, the distance will be 0, but I put this one, the distance will be 2 with a greater. So I accrue by this one and return 2 and add 2 into my 5 and add 5 into my list. Yeah, that's the general idea. This is the general idea. So actually the idea is just we maintain the occupy and consider the interval and the left bound and the right bound. That's all. Actually that this operation will take on the remove here, or the insert here will take on. Actually that Python, but this operation is quite fast in Python because they implement in C++ under hood and some optimize, so it's faster. So with this number of cores, right, the time complexity will be O n square, and the space complexity will be O n. But this one is very fast. This one have some balloons as well. O n square. But Python already have a soft click. Let's change to soft click. Let's go to a node application. Okay, this is my code, right? So let's change this one to the soft click, because if we use array here, right, the insert here, it will find the index. Can be used by research to find the index, right? When it insert into array, it will move the element in the array, so it will take on. And the same with remove one element from array, it will take on here. So totally will be n square here. So in Python we have something like soft click, soft clicks here. Okay, soft click here. It is 0, right? We just abandon s 0, and we can have the same operation. This one we just add answer here, and this one we just pop. Okay, let's test soft click is not defined. Actually that soft click is this library. Soft click, we need to import the soft click. This one maybe have something problem. Right, when we pop in Decode pop element, the support to pop element. Soft click, is there any operation to delete pop? Or remove? How about remove? we can remove. Yeah. Why longer? Yeah, because short click under the hood they implement like each interval we have 1,000 element. Short click here. Add here. Then again. So by using short click we can achieve n log n. For about the short click, I already explained one post about short click. The URL, right? URL leetcode.com URL site. URL, right? Okay. Leetcode.com short click. No. Why I cannot show you this site? Yeah, short click here. Yeah, so I have the post here. Yeah, I have the post here to explain the short click under the hood, right? I have the post here. Explain short click under the hood. So actually that basically it divide the big problem into smaller sub problem and store element into subclick. Each subclick have a store up to this one. So each operation now we will insert shock here, we will log n and remove here we will log n. So the total complexity will be n log n. Okay, I think that's all for today. Thank you guys for watching. I will see you guys on the next live streaming session. Bye bye.